Lesson 1-7, Day 2, Functions. The essential question for this lesson is how do you solve an equation in function notation? The definition of function notation is a function written in equation form. So everything we're going to deal with today is a function, but it's written as an equation. So for each example, we're going to write the equation in function notation. This might be a little bit confusing at first, but I think you'll catch on after a couple examples. So we're going to look at this equation right now. What we care about is the variable that's with the other numbers. So we have the y on the left by itself. We don't care about the y. What we care about is the x that's next to the 3. And the way you write function notation is f of, and then whatever variable was in the problem. So in this case it's x, so f of x equals, and then we're just going to copy the 3x minus 5 down. So we put this x in here because of that. All right, looking at the next one, t equals 4s plus 2. The t equals, we're going to leave that by itself, and the variable we notice next to the 4 is an s. So since it's an s, this time it's going to be written as f of s. The way that you pronounce function notation is f of, and then whatever variable it is. So f of x, f of s. And then we're going to continue writing 4s plus 2. Third example, n equals negative 2m minus 7. We've got that m there. That's what I'm going to circle this time. So that's what variable I always want. So f of m equals negative 2m minus 7. And last we have g equals 9h plus 8. Since the variable is an h, when I write my equation, f of h equals 9h plus 8. I'm going to go back to the vocabulary page now, and we're going to add that in. So function form is most often looks like f of x, and it's written as f of x. If you want to write an example, we could give one from the last page. F of x will say equals 2x plus 5. So what that means is if you graphed that equation, it would pass the vertical line test. And the reason we know that is we know it's a function. It's written in function notation, and in order for a graph to be a function, it has to pass the vertical line test. All right. Now we've got two equations we're going to be working back and forth between. F of x equals 3x squared, and g of x equals 4x minus 5. Now you'll notice that g of x is different than some of the examples we did on the last page. Even though it's g instead of x, or g instead of f, it's still representing a function. It doesn't matter which variable is on the left. All right, so we're going to evaluate f of 4. So the first thing I want to look at is that this is an f. Since it's an f, that means we're going to use the top equation here. F of x equals 3x squared. So f of x equals 3x squared. Now, since it's f of 4, that means we're replacing the x with a 4. So we could put the 4 in here and a 4 in here. One important thing to know about function notation is really that it's just a fancy way of saying y equals. So this is just like saying y equals 3 times 4 squared, which if we follow PEMDAS, we have to do our exponents first. So 4 squared is 16. 3 times 16 is 48. And there is our answer. G of negative 2. So since this one is G, we're going to use our bottom equation. G of x
Adam Qualley, please call
equals
6807. Adam Qualley, call
4x
6807.
minus 5. And then I'm going to take, instead of this x, I'm going to replace it with negative 2. So G of negative 2 equals 4 times negative 2 minus 5. Remember, again, that's just a fancy way of saying y equals. So 4 times negative 2 is positive, or negative 8 minus 5 equals negative 13. That's our answer.
Chris Foss, please call 6807. Chris
And
Foss,
the
please
last
call
one.
6807.
F of negative 3. So this one, we're going to use our F equation again, and this time I'm going to just go a little bit faster, so I'm going to already start by putting the negative 3 in here, and then I'm going to replace x with negative 3 as well. Now when I'm solving this and doing my exponent first, this is the key to remember. Negative 3 squared is the same as negative 3 times negative 3, which means a negative times a negative makes a positive 9. Very common mistake on a problem like this. So 3 times positive 9 gives us 27. All right, 2 new equations. We're going to do the same thing. So the first one, f of negative 1. I'm going to write down f of negative 1. And then I'm going to replace negative 1 into my x value. So 4 times negative 1 squared. This is just like the last one, where if I have negative 1 squared, it's the same as negative 1 times negative 1, which equals positive 1. So 4 times positive 1 equals 4. G of 4. So I'm going to take my 4 and plug it into my variable. G of 4 equals 5 times 4 minus 3. So really you'll notice we're plugging that number into both the x's on the problem, but really what you're trying to get is one number for your answer. 5 times 4 is 20. 20 minus 3 is 17. And last, f of 2. So if I've got 2, I'm going to plug it into both the x's in my problem. F of 2, remember that's just a fancy way of saying y equals 4 times 2 squared. So exponents first, 2 squared is 4. 4 times 4 equals 16. Two more examples. F of m plus 5. So this is where it gets a little bit more complicated. We are going to take m plus 5 and plug it in again here and here. So f of m plus 5 equals 3. And then since it's m plus 5, it's 2 parts, I'm going to make sure I keep the m plus 5 together and put it in parentheses, plus 2. Now this one's going to be a little bit different than the last one. If we think back to lesson 1-4, we did something over and over in that lesson when we had a variable outside a parenthesis, and that was bomb it. So that's going to be my first step. 3 times m is 3m. 3 times 5 is 15 plus 2. Now we're not done. We have one more step. There are 2 things we can combine in this problem. The 15 and the 2 are like terms. The 3m has to stay by itself because it has an m next to it. So 3m, and then if I combine 15 and 2, I get 17. And the last one. G of t plus 1. So I'm going to take t plus 1, and I'm plugging it in the G equation right there and there into the x's. So G of t plus 1 equals 2 times t plus 1 minus 1. I'm going to do the same thing as the last problem and bomb the 2 to the t and the 1. 2 times t is 2t. 2 times 1 is 2 minus 1. If I do my underlining, 2 and negative 1 are like terms. 2t stays by itself. So 2t and then 2 minus 1 is 1 plus 1 gives me my answer. Click and drag. So what we're going to do on this page is we are going to figure out which number on the right hand side, the black numbers, would answer our equation on the left. So if the first one in red says find f of 3, that means I need to plug 3 into my variable. Remember, I could write a 3 here as well. F of 3 equals 3 squared plus 4. 3 squared is 9. 9 plus 4 is 13. Second one, find f of 8. So if I plug 8 in here, and I say 8 plus 2 is 10. One. So f of 1 equals 8 minus 1. So 8 minus 1 is 7. F of 5, plug the 5 in here and here. 5 squared is 25. 25 minus 5 gives me 20. Negative 4. F of negative 4 equals negative 4 plus 8, which is positive 4. And last, we have f of positive 4. So f of 4 equals 4 squared. 4 squared gives us 16. Summary. And the homework assignment is pages 49 through 50, numbers 11, 13 through 14, 17, 33 through 36, 41 through 42.